students. I welcome you all once again within this online lecture series. Last time we were talking about one of the laws from laws of chemical combination, that's law of constant composition, also called as law of definite proportions. And regarding this law, firstly I told you people that it was actually Lavoisier, Antoine Lavoisier, the French chemist, also known as father of chemistry. Lavoisier and other scientists like J.L. Proust observed that many compounds were composed of two or more elements. And in last video lecture, I told you people that whenever the two elements combine with each other, there's always the formation of a compound. And same is the case with this law. And in Lavoisier and other scientists observed that many compounds were composed of two or more elements, and each compound had the same elements in the same proportion. And they said one more thing. They said that irrespective of the fact from where compound came or who prepared it, this led to the formation of a law, and this law is called as law of constant composition, also called as law of definite proportion, and it was given by the French chemist J.L. Proust. J.L. Proust. So regarding this law of constant composition, I told you people that in a pure chemical substance, the elements are always present in definite proportions by mass, and this is also known as law of definite proportion. This means that what I am telling you is that in a pure chemical substance, the elements are always present in definite proportion by mass. This means that whenever whatever may be the source from which a compound is obtained, it's always made up of the same elements in the same proportion by mass. We discussed it last time. One of the brilliant examples of the law of definite proportion, that was water. For example, whenever there is a formation of a water, the chemical formula for water is H2O. Whenever there is a formation of a water, there is, it's like this, two hydrogen atoms and one oxygen atom. That means whenever there is a formation of a water molecule, hydrogen and oxygen combine with each other, and there is formation of a molecule, that is, I can say the compound, that's water. And I told you people that there's always the ratio 1:8. 1:8. That means one part of hydrogen, whenever the one part of the hydrogen reacts with 8 parts of oxygen, whenever the one part of the hydrogen reacts with 8 parts of the hydrogen, then water will get formed. Otherwise, it is that impossible for we people to make water without this proportion, I mean to say. That's why this is also called as law of definite proportion. You will see in water, whatever may be the source, there is always the constant composition. There will be always the definite proportion. That's why what actually this J.L. Proust said in his statement, he told that in a compound, what is a compound? The constituent elements. What is composed of two constituent elements, like one is hydrogen, another is oxygen. Elements are always present in definite proportion by weight or mass. That's why I told you people there is always the ratio of 1:8. For example, in the last video lecture, I told you people that if we will decompose water, for example, these are 9 grams, 1 gram of hydrogen reacts with 8 grams. That means almost the total mass is 9 grams. If we decompose 9 grams of pure water by passing electricity, for example, if we carry out the electrolysis of water, electro means by passing electricity and lysis means breakdown. So whenever we decompose 9 grams of pure water by passing electricity through it, then 1 gram of hydrogen and 8 grams are always formed. 8 grams of oxygen, for example. Let me make you clear. This is water. The moment we will pass electricity through it, electricity means we will carry out process of electrolysis. Whenever we carried out the process of electrolysis as far as this water is concerned, the moment we will pass electricity through this water, there is always the formation of hydrogen and oxygen. And we will come to know that this oxygen, this water is wholly or solely made up of hydrogen and oxygen, and there is a formation of 1 gram of. So as far as this water is concerned, this water, I told you people that whenever we carry out this process of electrolysis, means the moment we will pass electricity through this water, there is always the formation of hydrogen and oxygen, and this hydrogen and oxygen is in the ratio of 1:8. Means the moment we will carry hydrolysis, I can say this electrolysis of this water, means that the moment we will pass electricity, electro means passing of electricity, and lysis means breakdown. Lysis means breakdown. That means the moment we will pass the electricity through this water, there is always the formation of 2, I can say, elements. One is hydrogen and another is oxygen, and in the ratio of these elements have been combined in the ratio of 1:8. Then and then only this water molecule got formed. So that means that if we decompose 9 grams of, the moment we will decompose 8 plus 1, that means 9 grams of water. The moment we will decompose 9 grams of pure water by passing electricity through it, then 1 gram of hydrogen, that means 1 gram of hydrogen and 8 grams of oxygen are always formed. That means if we repeat the experiment by taking pure water or from different source like pond, well, river, sea, etc., the same mass of hydrogen and oxygen will be obtained in each case. That means this experiment shows that water always consists of 2 elements. One is hydrogen, another is oxygen. And these water and oxygen elements have been combined in the ratio of 1:8 to form this water molecule. That's why I told you people that this law is also called as law of definite proportion. Means it's not necessary that from which source you people are getting this water. It's actually the moment you will get this water, there will be always the ratio of 1:8, whatever may be the source. That's why I told you people this law is also called as law of definite proportion. That means in a chemical substance, this water is a chemical substance. In elements, one element is hydrogen, another is oxygen, are always present in definite proportion. Definite proportion means 1:8 ratio. This means that whatever may be the source from which a compound is obtained, it's always made up of the same elements in the same proportions by mass. There's a validity of the law of definite proportions. So this example is in accordance with the law of definite proportion. So according to the law of definite proportions, also called as constant compositions, a pure chemical compound always contains same elements combined together in the same proportions by mass or weight. So let's discuss some more examples. Another example of the law of definite proportion is the formation of a carbon dioxide. For example, carbon dioxide, this is carbon dioxide, can be formed by burning coal. For example, this is coal. The moment we will pass oxygen through this coal, oxygen has ability because it helps in burning. So that's why I told you people, the moment we will burn this carbon in presence of oxygen, there will be always the formation of a carbon dioxide. This is one method. The second method is that whenever we burn methane, means we carry out the combustion process of methane in presence of oxygen, there is always the formation of carbon dioxide plus water. So these are actually the two processes. I will quote one more process, like whenever we burn calcium carbonate, or the moment we will heat this calcium carbonate, there is always the formation of a carbon dioxide. So carbon dioxide can be prepared by 3 methods. One is by burning coal. For example, the moment we will burn this coal in presence of oxygen, there is always the formation of a carbon dioxide gas. Mark my words. Whenever we burn this methane, CH4 is the formula of a methane, also called as natural gas. The moment we will burn this methane in presence of oxygen, there is always the formation of a carbon dioxide gas plus water molecule. And the moment we will heat the limestone, the formula of the limestone is calcium carbonate. The moment we will burn this calcium carbonate in presence of oxygen, there is always the formation of a carbon dioxide gas. That means that it has been observed that each sample of carbon dioxide gas, for example, carbon dioxide gas is obtained in this process as well, in this process as well. This means that it has been observed that each sample of carbon dioxide obtained by above methods contains carbon and oxygen in the ratio of, mark my words, in the ratio of 3:8. 3:8. That by mass. This means that carbon dioxide always contains two elements. One is carbon and oxygen, and these are combined in the ratio of 3:8 by mass. In other words, 3 grams of carbon will always combine with 8 grams of oxygen to form carbon dioxide, or I can say 6 grams of carbon will combine with 16 grams of oxygen, or 1 gram of carbon will combine with 8 by 3 grams of oxygen to form the carbon dioxide. So from this discussion, you people should know that, or you people should keep in mind that whenever there is a formation of a carbon dioxide, this can be formed by any of the processes like burning of a I can say coal, I can say burning of these calcium carbonate, marbles, limestones, by heating the limestones, or by burning of this marsh gas. In three cases, in these three processes, there is always the formation of a carbon dioxide gas, and it has been observed that each sample of the carbon dioxide gas, this carbon dioxide gas, carbon dioxide gas, carbon dioxide gas, each sample of the carbon dioxide gas obtained by above methods contains carbon in the ratio of 3:8. That means 3 grams of carbon have been joined with 8 grams of oxygen, and then carbon dioxide gas have been formed. So this is in accordance with law of definite proportions. So this was another example of the law of definite proportion. Let's discuss one more example regarding this law of definite proportions. We will continue. So few examples. Let's discuss some more examples regarding this law of definite proportion. For example, this is potassium reacts with chlorine, forms KCl. This is element 1, this is potassium, this is chlorine, and there is always the formation of a compound, that's KCl. This is potassium chloride. Potassium chloride. And it has been experimentally proved that 39 grams of potassium reacts with 35.5 grams of chlorine to form KCl. So the ratio is 39:35.5, means 30 grams of potassium have been react with 35.5 grams of chlorine, then only this KCl get formed. So that means that this example is also in accordance with the law of definite proportion. That means that there is a definite proportion between potassium and chlorine, then only KCl gets formed. So whenever I talk about this law of definite proportion, this means that in a pure chemical substance, a pure chemical substance formed of potassium and chlorine, the elements, one element in this compound is potassium, another is chlorine. The elements are always present in definite proportions. Whenever you people will see KCl, there will be always ratio will be always the 39:35. That means this example is in accordance with the law of definite proportions. So this was regarding the law of definite proportions. In next video lecture, inshallah, we are going to discuss some more examples regarding this law of conservation, law of definite proportion, to make you people understand what actually this law of definite proportions is. And further we will solve some of the numericals regarding this law of definite proportions to make you people understand I can say more and more regarding this law of definite proportions. Till then, stay safe, stay at your homes. Allah bless you all. Thank you for watching this.